Probably, before we start all the operation, I can briefly go through the menu. There is file, we can save spectrum and this connection. If I unuse this connection, you see it disappeared from here. And it happens for all the software windows you have. Then spectroscopy, acquisition parameters. In advanced settings, you would have the threshold stability. It's for the inbuilt reference channel. In order to skip the bad spectra, you can optimize this threshold. We can try it later. Then laser time limits, if you want to turn off the laser after certain operation. Let's say you operated at very hot temperature and you want to restrict using it after 10-20 minutes. But we have no limits right now. Then you can select some very advanced settings, like you can see the image sensor and do binning of spectrum collection. Then laser parameters, they are here. This is most important, and here you select the laser power, turn on, turn off laser, exposure time, and capture number of repetitions for laser number 1 and laser number 2. Here you can see the actual power calibrated after the before the probe, and the number of hours laser was working in total. You can see that 785 laser was working in total after manufacturing 11 hours, and the red laser was working almost 2 hours. You have a question? No?
Yeah, maybe later. Are they working at the same time?
No, they
one after the other one?
Sequentially. And by the way, you should not worry. You can turn on another laser, the previous will turn off by itself.
Okay.
So you don't need to turn off it, and you can just switch. Then in spectroscopy we have plots like Raman shift from 675, 785. Let's say I unplug one and they disappear, and then I unplug another one and they I activate it and they appear. We also can monitor the wavelengths, not shift from laser, but just emission in nanometers. Then we have pre-processing, smoothing, Savitsky Gallet, different types, live smoothing, and as post-processing, baseline correction with rolling circle and other methods. Background correction, if your Raman have their own Raman spectrum, you can compensate on it and have zero. And transmission correction. This transmission correction you need if you want to compensate on different transmission of your Raman filters inside, and grating, dispersion, sensitivity for every wavelength, and basically all of the optical elements and even the sensor. Because you also compensate. This transmission was measured by black body source, like a tungsten lamp, and we also normalize at known temperature. The source was, so we also normalize on quantum efficiency. So you have correct peak ratio for Raman spectra, and we can try that. Then data analysis, it has a lot of features. We can go into it when we collect something. Raman mapping, this when you operate in a microscopy mode, and we don't really need much of that. However, we can do time mapping, collect Raman spectra versus time. And this is very important part of the Raman mapping, where you don't need any motorized stages. In the view, you can change the layout of the, let's say, the temps. It's now dark, you can go to the light one, and it will look differently. Like this. Sometimes it works. Let's say when I do the presentations, it may help. But usually in the lab, dark mode is better. And we have dark green, dark red, and so on, and light green, red, and so on. Help is for configuration settings. And there is also some preferences. Let's say if we like the windows as they are here, we can save them LOD preference, and then if I turn off some of the windows and I want to return back as it was, I don't like this, I go in View, Preferences, and I select the preset, and it will be as it was before. This is very useful. Each user can select his own windows, how how he or she likes it and operate. Good. Now we turn on the laser. First of all, it's a laser safety. So if I turn on the laser and there is no probe, it's a parallel beam. You can see there is a dot, yes?
Yes.
And it's parallel. It's very dangerous to direct it into your eyes, as dangerous as the laser pointer we used during the presentations, comparable power and so on. There is another laser, red one, and you see it way better. They all class 3B, which means we can look on reflection from non-mirror surfaces without eye protection, but we cannot direct into our eyes. It gets way simpler if you, of course, use some Raman probes. Then your laser is very spreads and power density is significantly less, so it's already more safe, of course. So it's recommended not to turn on the laser without the probe because it is more dangerous. Beam is collimated. Good.
Can we use it directly after we turn on the laser, or should we wait that the laser stabilizes?
We can. Depends on the type of experiment. If you need really precise quantitative analysis, we suggest around 30 seconds to wait after you turn on. But for identification and some other type of experiments where you do not expect quantification accuracy better than 1%, you don't need to wait. Immediately you turn on the laser and it's ready to go.